In this session, we solve a problem from the book by Seborg, 3rd edition, exercise 4.3. A transfer function is given between the measured pressure and the real pressure. So the behavior of process sensor, sensor or transmitter can be expressed as a first order transfer function. So this is given by 1 over 30s plus 1, meaning the gain is 1 and the time constant is 30 seconds. What you are required to do is that if the pressure suddenly changes from 35 to 50 psi at 1:10 p.m. and if an alarm sound, if the measured pressure reaches 45 psi, at what time will the alarm sound? So let's look at a quick analysis of the problem. So we're given the transfer function between Pm and P itself. So what it says that the pressure goes from 35 to 50 psi. Now, as you said that the gain is 1, so meaning that initially the measured pressure was also at 35 psi, you can assume that, and also it will go to 50 psi. So if the measured pressure is here, it will eventually go to 50 psi. So what you are asked to find out that if an alarm sounds at 45 psi, so when the alarm will sound, meaning that when the measured pressure will reach 45 psi. To analyze the problem, we have P prime T is going from 35 to 50 psi, so that 50 minus 35 psi equals 15 psi. So we need to find out what is P prime S, which is will be 15 over S, and then we have to figure out what will be this P M. Okay. And when you find that expression for Pm, you need to find out T for Pm equals 45 psi. So that's the procedure to follow for this particular problem. Now let's look at the solution. So to find out Pm, we need to find out Pm prime. So you know the relation between Pm prime and P, and we can use that to get out Pm prime, and then Pm will be simply Pm at the initial state plus this Pm prime. So we have for this P prime S equals 15 over S, we get Pm prime S over P prime S equals 1 over 30S plus 1. So for this given P prime, we'll have Pm prime S 1 over 30S plus 1 times 15 over S. Now we know that the Laplace inverse of Km over S times tau S plus 1 is given as Km 1 minus its negative P over tau. We'll directly use this relation for this case. So we have Pm prime T will be, for our case, K equals 1, M equals 15, and tau equals 30. So we'll have 1 times 15, 1 minus its negative P over 30. Okay. So that's the Pm prime. Okay. So we know that Pm at the initial value it was 35 psi. Initially the measured value was at 35 psi. So Pm in its absolute form will be Pm bar, meaning the initial value plus this Pm prime T. So that's also P. So we have this equals 35 plus here we have 15 times 1 minus equal negative t over 30. So problem to find out is that when will this Pm will be 45 psi. So what will be the T for this case, because that's the time when the alarm will sound. So if you denote the TA, represent the alarm time, we'll have 45 with the time. So 45, that's the value when the alarm will sound, equals 35 plus 15 1 minus TA over 30. But TA denotes the time of the alarm, because that's the time when it will be 45. Now if you do this further simplification, you will have, just simply take it over here, 10 over 15 will be 1 minus the negative TA over 30. Simply this will give you, take this on the other side, negative TA over 30 will be negative 5 over 15. So this just to simple numerical calculation here, simply negative TA over 30 will be natural logarithm of 1/3 this gives us negative TA over 30 will be negative 1.1. So this will be TA to be 33. So we know that the time was in terms of seconds. So it will take 33 seconds for the alarm to ring. So the alarm will sound at 1:10:33. So that's the answer we need to find out.